A Ferris wheel has a diameter of 10 meters and makes one revolution in 8 seconds. A person with a mass of 68.4 kilograms is standing on a scale for some reason in the Ferris wheel. What is the weight in newtons that the scale reads as the person passes through the highest point of her motion? Okay, so let's draw a picture of this. So here's a Ferris wheel. Now when you're on a Ferris wheel, you're always at the top of the Ferris wheel for your whole motion around. Okay, so you're going around and you're always on the top of it. You never get flipped upside down like in a loop-de-loop. So when you're at the top of the Ferris wheel, you're right here. And the question is asking, what weight does the scale read? So you're standing on a scale. Now a scale will always read the normal force. So the question is actually just asking for what is the normal force, okay, acting on the person. Okay, so if we were to draw a free body diagram of this person at the top of the Ferris wheel, what forces would we have? So we always have a force of gravity which points straight down, Fg, and we'd also have a normal force since the object, the person, is standing on the surface, on the scale. The scale pushes up on the person going like this. Okay, so which of these two forces should be bigger, the normal force or the force of gravity? Well, think about the motion of the object. At the top of the Ferris wheel, this person is traveling in a circular path. And which way does the net force always point when you're traveling in a circular path? The net force always points towards the center of that circular path. Okay, so then if the net force is pointing to the center, that means the force of gravity needs to be bigger than the normal force, right? Okay. So let's start off by finding out what that force of gravity is. Force of gravity is equal to mg. Since we're close to the surface of the Earth, we can use this simple formula, where m is the mass of the person, 68.4 kilograms, and g is 9.8 meters per second squared. So I'll just type that in my calculator, and I get 670.32 newtons. Okay, so now we know the force of gravity. It tells us that the diameter of the Ferris wheel is 10 meters, which means that the radius of the Ferris wheel, which is half the size of the diameter, would be 5 meters. And it makes one revolution in 8 seconds. So what value are we able to find? What variable can we find if we know it makes one revolution in 8 seconds? We can find omega. So omega is 1 revolution per 8 seconds. Now that's not the standard international unit for omega. Omega, the angular velocity, should be in radians per second. So let's change revolutions per second to radians per second. So I'm going to put revolutions on the bottom so it cancels out, and radians on the top. So we end up with radians, and 2 pi radians is the same as 1 full revolution. So if we multiply these numbers on our calculator, I would just type 1 times 2 pi divided by 8, and I get pi over 4. So my omega, my angular velocity, is pi over 4 radians per second. Now we know omega and r, and we're looking for our normal force. So if we were to draw a free body diagram, well, we drew the free body diagram here, we could say, okay, the positive direction here, we're talking about the radial direction, which points towards the center of the circle, is pointing downwards. So my F net in the radial direction is equal to mass times radial acceleration. My F net in the radial direction then, if down is positive, would be Fg, which is positive, minus the normal force, since it's pointing away from the center of the circle, equals the mass, okay, this is the mass of the person, times the acceleration. Well, the radial acceleration, if you remember, there were two formulas that we could use to get it, v squared over r, or omega squared r. Those are two formulas that we could use to find radial acceleration. So since we know our omega, we're going to use the omega squared r formula. Okay, so remember, we're looking for the weight that the scale reads, which is the normal force. So we're trying to solve for this normal force. So let's rearrange our formula. Okay, so Fn is equal to the force of gravity, which we already found, 670.32, minus the mass of the person, which was 68.4, times omega squared, pi over 4 squared, times r, 5. So I'm just going to type this up on my calculator. And I get 459 newtons. Okay, notice in my question I have 3 significant figures, 3 significant figures, and 3 significant figures, so my answer should also have 3 significant figures. So I'm all good. Thanks for watching.